Hello everyone. This video is going to focus on our second very important Python module, Pandas. Basically, it's just going to be a brief introduction to Pandas and how, whether it's features that are helpful for data analysis. Okay, Pandas. Basically another Python module, but specifically designed for data analytics. So here, if we want to import pandas, we say import pandas as PD. Similar to NumPy as NP, sort of this agreement among all the data scientists to be referring to as NumPy when we are working with in Python. Also, PD is that sort of agreement that everywhere you see PD, probably someone has imported pandas. So let's keep with that. So we import pandas as PD most of the time. Pandas has two types of data structures, basically series and also data frames. We will see in a minute that basically data frames are collections of series. And by these two types of data frames and data structures and their many different properties, you can basically do a lot of manipulation and analysis on any types of data sets. So let's get started on all of them. Series basically are a one-dimensional data. You can think of them as one column of data. So for example, here I have a list that include these elements. And if I want to turn that into a series, I'd say PD, which we imported pandas. This we say series. I want this to become series. As you can see, it assigns a sort of a column name and also assign indices to your data. So this is a series. If I wanna get access to its different elements, like a list, I could say my series 0, it gives me the value 1, and then I could say my series 1, it gives me the value apple. So series has indexes, as we saw. So for example here, I could have this series, which is Emily, IME, and 3.7, which we could, as human, we could say this is a name, this is the major, and this is someone's GPA. Because we are in a college experience, we are primed to think of these things. But as a machine, we might not be able to do that, so we can take advantage of the fact that series can allow us to give indexes or indices to our elements of the series. So I call say index. So this is my list, and when I want to change that into a series, I also create the name of the indices. So I'd say the first one is name, and then it's major, and then it's GPA. So once I run this, now I have a series that has name, major, and GPA. And I also can say, for example, what is the name from this series. What is the name from this series? And it says Emily. So pay attention, when we are working with series, it's important that we are passing the name as a string, because it's a string that is the index here, not a variable name. So that's sort of the heads up here. So you cannot just say name. But pandas is very strong, and you could actually say s dot name, because once you create a pandas data frame or series, all of the columns will be also sort of like a property of that data frame, which makes coding with pandas very easy. So that's a significant improvement to a lot of other programming languages. You could have done the same thing. You could have also refer to it by S0, which is basically the the index, the original index, or the universal index, even though that you have changed your indexes that you have, but there is also that universal index that still is going to be on the background. You can be using it. Or you could also be just doing the same thing by saying s.iloc, which is I location. It's gonna give you the same value. Or you could say s.loc, which is the location. And with the difference between iloc and loc is that loc works with the indices that you have provided, or like there are the pandas, there are the series indices. iloc is working with the universal indices of any series or any data frames. So that's their differences. And also s.name. So these are the very different way you could access the series. And you can see it's much more versatile than just a simple list. So next, let's talk about DataFrame. And most of the time in this course, we'll be working with data frames. And data frames are basically a collections of series that are put together to create this concept of data frame. And you can think of data frame as like a table in an Excel with rows and columns. And it's a very simple structure that we are all used to seeing. So if I want a data frame with names, date, shares, and prices of some stocks, once I can create it like this. I now have 3 stocks with their dates, shares, and prices. As I said, it's very simple, as it's like a table that we are already familiar with. And we could be accessing the rows and the columns very easily with DataFrame. We could also be adding the columns and rows very easily. So for example, I could simply add a new column here. I could add a column owner by just saying df owner, and I just want it to be unknown for now. And now I have an owner for all of the rows. I also could be changing the indices. So there are 0, 1, and 2. I could simply say I want them to change to 1, 2, 3, or anything that I want. And the indices is going to. I could also be choosing another column to become the index, or the index column. I could just simply say SetIndex and say I want the column name to become the index, which makes intuitive sense. So once I run this, now I can see that name is the new index for this data frame. But if I had run this in this way, the way on the top, I wouldn't see any change. My indexes still were 1, 2, and 3. And but when I do run this code this way, it does work. And if I run the third chunk here, I can see that this still does not work. So basically only in this part of the code sort of work for me. Before continuing to watch this video, think about this for a second and come up with reasons. What's happening here? What's the mechanism of pandas and data frames that creating this situation? Try to think what it could be and then continue watching. As you might have guessed, what's happening here is the fact that SetIndex is simply a function, and it outputs a data frame with the changes that has been made through the function. It does not change the main function itself. So when I say df.setIndex and I want name to be the index of the column names to be index of this data frame, it does not change the data frame itself, but it spits out a new data frame that has that column as the index. But once you say df, it just basically is going to print out the original df. That's why it's not working the way we were assuming it would work. But once I do this, since there is no other printing here, it will print out the output of this function. So now I can see it. But still, that does not mean that the df has actually been changed. So to resolve this, there are two ways. You could, once you run the function, you could say, okay, I want the df to be recorded in itself. I could be say, okay, whatever you have, whatever you're spitting out, put that in yourself. And then once I run this, now it works. Or let me run this again. Or I could say simply df in place is true. So basically, now we have a function that changes its own data frame. So this is changing the function in a way, instead of spitting out a new function, we tell the data frame that also we want yourself to be updated by saying in place is equal to true. And once we do that, and now we have what we were looking for. Very similar to series, data frames also have very powerful accessing. So you could say df dot any columns, and it would show that column for you. Or you could say use the name of the column in brackets by the as a string. It would also return the same things for you. You could also access each row by different mechanism. You could use the universal indexes by iloc, or you could be using the lock, which is you have to now use the indexes that are assigned to the data frames. So df lock. So pay attention if I say df lock 0, this is not gonna work because it literally looks for that index column and it says there is no 0 there, and it's going to be an error. But if you said AA, which is the name of one of these stocks, then it will return what you're looking for. You could also be saying iloc and treat the data frame as a matrix, and it will just bring that one value for you. So it will bring that AA, which is which is going to be like IBM 0, 1, and then the columns 0, 1, and then the columns. So it's going to be 30, and that's what we have here. Or you could have done the same thing by just saying lock, which is basically saying bring this series for me, and in that series bring the shares for me. As you remember, data frames are collections of series. So once you get a column, that column or that row is a series. And basically that's how it works. And then you could also use df.at, which is basically doing the same thing as lock or iloc, but now you are working with the name of the indices or the column. Every time you capture a row or a column in a data frame, you basically are working with a series. So this is a column, and it's a type of series, and also it's a row. That one is also a series. Do you see? So both columns and rows are series in a data frame, and the data frame itself is a form of data frame. One difference between series and data frames is the fact that you could be saying df ilog without so let's say s1, which is our series. You could be using s brackets and start like using indexes with series, and it will work perfectly. But with df, if you did that, it's not gonna work. It's not gonna just bring anything for you. It's just gonna give you an error because it's confused. Are you asking for rows or columns? For you to be able to sort of use the rows, because I think that's what someone might do, you would have to use df.ilog. That would bring that rows for you.